Anuruddha Kempitiya again. Okay, last episode 3, we talk about very important concept where we build up the relationship between mass of a one particle and mass of a physical quantity or chemical quantity. We can measure it in our school lab. Mass of one particle. We took the example carbon, mass of one carbon atom. Very small. It's a microscopic quantity, even we can't see or we can't measure it. But you can measure it using mass spectrometer, which is impossible in our school lab. However, we talk about some physical quantity which is easily measured in our school lab. So we are going to extend the same principle, same concept into a different substance. This time I have taken the example water. Water is a molecular substance and it is a compound. It is not an element. Last week we took an element, carbon, right? Okay, you can measure the mass of one water molecule with the help of mass spectrometer. Otherwise, you can get the average mass of oxygen atom and hydrogen atom from the periodic table, and you can get the total mass of water molecule. Right. Then one water molecule, mass of one water molecule is equal to 18 U, atomic mass unit. Or else you can tell relative molecular mass of water is 18. Right. That is just a one water molecule, very small. Now we are going to take some mass of water. Right. You can see in your scale, on your scale there is a water beaker. There are a lot of water molecules. So mass is indicated as 18 grams. So 18 gram is a macroscopic quantity that we can see and we can measure in our school lab. But this is not one water molecule. There are a lot of water molecules, very large number of water molecules. Okay, after measuring 18 grams, see the similarity, 18 U, 18 gram, right. Then after measuring 18 gram, what is our next step? Okay, next step is to count the number of water molecule. Right, here one water molecule, 2, 3, 4, 5. We'll end up with very large number of water molecule. We can write it like this, 6.022 times 10 to the power 23 water molecules. That is a very large number. Right. Okay. Then next, what did you do? Next, this water molecule, if we have 6.022 times 10 to the power 23 water molecules, or in other words, 18 grams of water, this quantity of water is defined using a different way. This quantity also called 1 mole of water. 1 mole of water. Right. Then finally, so mass of water inside the beaker is 18 gram. That is also called 1 mole of water. Then putting these two concepts together, we build up another relationship, molar mass of water. Molar mass of water is 18 grams a mole. So that is a different way of telling the quantity. That is also physical quantity. Molar mass of water is 18 grams per mole. Right. So these are the concepts. Now we have a very good relationship. One water molecule has the mass of 18 U, or relative atomic mass is 18. Then if we take 18 grams of water, there are 6.022 times 10 to the power 23 water molecules, and that quantity of water, that amount of water, also called 1 mole of water, and the molar mass of water is 18 grams per mole. Right. Then we can find out some relationship with other quantities like this. Okay, 18 grams. Then 18 grams mean 1 mole. What if I take 36 gram? twice as 18, then that obviously should be 2 moles. 54 grams, that should be 3 moles. Okay, we can use that relationship to talk about other quantities. Right. Again, I have 18 grams. How many water molecules? 6.022 times 10 to the power 23. Now I am going to take 36 grams. How many water molecules? Obviously, it should be twice as this. That is 12.044 times 10 to the power 23. Like that. Again, I have 1 mole of water. Then how many water molecules? 6.022 times 10 to the power 23. What if I take 3 moles? So you have to multiply this value by 3. Then 18.066 times 10 to the power 23 water molecules in 3 moles of water. Right, like that we can use these relationship for calculations. Also, I want to introduce a new thing, that is standard symbol used in these calculations. Okay, number of water molecules, capital N. Capital N is used to denote number of particles, that is number of molecules or atoms or maybe ions. Right, capital N. Then number of moles of water, simple N. Here simple NH2O is equal to 1 mole. Then mass of water, simple M. Here simple MH2O is 18 grams and molar mass of water, that is capital M. Then capital MH2O is equal 18 grams a mole. You can find some mathematical relationship between these quantities. You will understand from this concept. There are some, we can build up some mathematical relationship. See, if you multiply number of moles from Avogadro number, that is 6.022 times 10 to the power 23, you will get how many water molecules? NH2O equal simple NH2O times 6.022 times 10 to the power 23. That is the first relationship. And also, if you want to get the number of moles of water, mass of water must be divided by molar mass. If you carefully watch this, carefully analyze this, you can simply build up these relationships. Okay, now we know if we have 18 grams of water, the number of moles will be 1. 36, number of moles will be 2. So if we are given some multiple of this, we can easily tell the quantity, number of moles as number of moles or number of molecules. But what if they ask, if we have 100 grams of water, then how to find the number of moles or number of water molecules? So we will now talk about that. The question is, you have certain water, quantity of water, the mass of that is 100 grams. They are asking how many water molecules. That is the question 1. So we are going to use this relationship to find out how many water molecules there. So mass of water is to number of molecules. See here 18 gram 6.022 times 10 to the power 23. Then 18 gram is to 6.022 times 10 to the power 23 molecules. Then what I am going to do, I am going to simplify this ratio. You know that ratio can be divided by same number both sides. There is no change in the ratio. And ratio can be multiplied by same number both sides. So there is no change in the ratio. So what I am going to do, I am going to make this 18 into 100. How do you convert 18 into 100? First divide by 18 and multiply by 100. So I divide both sides by 18. and then multiply by 100. Then I am getting this expression. If I simplify this side, I'll get 33.46 times 10 to the power 23. That is the number of water molecules. And you can write it as 3.46 times 10 to the power 23 water molecules. Also, you can do the same thing with equations. So we will see that method as well. In this method, first we find number of moles of water, mass over molar mass. And we don't need to simplify at this stage. Right. This is the number of moles. 100 over 18 is the number of moles. Then we convert number of moles into number of molecules. Number of molecules equal number of moles into Avogadro number. We use the symbol Na, Avogadro number. So 100 over 18 moles multiplied by 6.022 times 10 to the power 23 per mole. Per mole is the unit for the Avogadro number. So then you see that mole per mole cancels. Then you are getting unitless quantity, but actually that means the numbers, number of molecules. So you can say 3.346 times 10 to the power 24 now water molecules, number of water molecules. Question 2, this time your quantity is given as number of moles. They say in the beaker there is 4.8 moles of water. So they are asking how many water molecules there are in the beaker. So this is the method. We know that if we have one water molecule, the ratio is 1 mole of water contains 6.022 times 10 to the power 23 molecules. That means 1 mole is to 6.022 times 10 to the power 23 molecules. Then what I am going to do, I am going to multiply both sides by 4.8. So I am getting final answer 2.891 times 10 to the power 24 water molecules. Or else you can go for the equation. So number of molecules of water is equal number of moles of water times Avogadro constant. Then you are getting the same answer. This time question change. Your quantity tells as a number of water molecules. Number of water molecule in the beaker 3.011 times 10 to the power 24. That is the way that usually number of molecule comes. It's a large number. Then what is the mass of that water inside? Okay, this is the relationship. If we have 6.022 times 10 to the power 23 water molecule, that means exactly 18 grams. 18 grams of water. Then what I am going to do, I am going to convert this side into 1 by dividing both sides by same number 6.022 times 10 to the power 23. This side and this side both, right? Then I want to convert this 1 into 3.011 times 10 to the power 23. I multiply both sides by 3.011 into 10 to the power 24. Finally, when you simplify this side, you are getting 90 gram. That means mass of water in this container is 90 gram. Okay, we can use equation for the same calculation. This time you have to first find the number of moles. Always you have to find the number of moles. Right. Number of molecules equal number of moles times Avogadro constant. So number of moles equal divided by Avogadro constant. So we can substitute number of moles, number of molecules divided by Avogadro constant. Number of molecules is this, and this is the Avogadro constant. The mole per mole is the unit. Then you are getting 5 moles. So in this container, if there are 3.011 times 10 to the power 24 molecules, that means 5 moles. Then we can use mass of H2O. We can find number of moles times molar mass. molar mass of H2O. Then 5 moles into 18 grams per mole, so you are getting 90 grams, that is the mass of water in the beaker.